Namaste and welcome from New Delhi to our webinar Nanotechnology in India. Thanks for joining us. My name is Robert Luck. I'm the Austrian Trade Commissioner for India, and I'm very excited that we can present to you today this advanced topic from the sixth biggest economy in the world, which is India today. And it will soon become the fifth largest economy by overtaking France. The cities of Bangalore and Hyderabad are world-class high-tech centers today with an incredible skilled workforce. Nanotechnology, ladies and gentlemen, has an incredible wide array of applications ranging from electronics, textiles, construction, food processing to cosmetics and many others. The development of nanotechnology in India has the chief goal to improve the living standards, especially of lower income groups, like availability of drinking water, healthcare, and agriculture, which makes it even more exciting. In the meanwhile, substantial economic gains have been achieved through the growth in other nanotechnology-based industrial sectors as well in India. Perhaps not everybody knows in Austria that over 2,300 papers in nanoscience have been published in India over the past 5 years. As such, it ranked third in the number of papers published, only behind China and the USA. There has been also a significant rise of nanotechnology-related patent applications over the past 10 years in India, another remarkable success. Finally, I would like to mention the Memorandum of Understanding between the Austrian Federal Economic Chamber, the Austrian Institute of Technology, AIT, and the Indian Institute of Science, which has been signed last year to explore cooperation in the field of innovation in nanotechnology, biotechnology, applied sciences, and exchange of research programs. And this, ladies and gentlemen, brings me already to our distinguished speakers, which I would like to introduce to you with any further ado today. We have today with us Professor Govindaraju from the Jawaharlal Nehru Center for Advanced Research in Bengaluru, Mr. Prosanit Sen, Center of Nanoscience of Engineering, India Institute of Science in Bangalore, Mr. Siddhalingaya, CEO of the startup Precision Farmers in Bangalore, who will be our best practice example of a successful startup in India. And I would like to mention also, before I introduce the first speaker, that questions can be asked at any time, and all the presentations will be sent to you a couple of days after the seminar. And now I would like to introduce our first speaker, Dr. Honi Gaude, Managing Director of the Karnataka Science and Technology Promotion Society and Special Director from the Department of Information Technology, Government of Karnataka. He will bring us closer the perspectives of the Government of Karnataka regarding nanotechnology. Please, Professor.
Good afternoon from India. I'm delighted to welcome you all to this webinar on nanotechnology. I'm going to speak on the nanotechnology perspectives in Karnataka, as introduced by the moderator and myself, Honi Gaude. I'm the Managing Director of the Karnataka Science and Technology Promotion Society, and also the Director of Karnataka Science and Technology, Government of Karnataka. The Karnataka Science and Technology Promotion Society was established in 2012 under the Department of Information Technology, Biotechnology, and Science and Technology. This center is functioning as a nodal agency to catalyze and facilitate the promotion of the science and technology programs and schemes in the government, and as well as the monitoring, evaluation, assessment of the programs of all the schemes which are being implemented through Government of Karnataka. Now, as you are aware, nanotechnology refers to the study of the phenomena, the manipulation and engineering of matter, particles and structures on the nanometer scale. That is at the atomic and the molecular scale where properties differ significantly from those at a larger scale. So while the nanotechnology is the design, characterization, production, and application of structures, devices, and the systems by catalyzing the controlling at the shape and the size at nanometer scale, and thus leading to the use of new nanomaterials and nano-size components. And this will eventually provide us with the ability to design custom-made materials and products. So overall, nanotechnology is nothing but the development and use of techniques to study physical phenomena and develop new devices and material structures. Since the dimensions of atoms and molecules are in nanometers, this technology is called as a nanotechnology. In what way the nanotechnology is different from the bulk materials? In fact, it depends on the properties of the materials, particularly in terms of the electrical, optical, thermal, mechanical, even the reactivity with the surface. In fact, the bulk materials, when we convert into a nanoparticles, they will have a more surface area to contact with the surface. And with this, actually, we can precisely develop various nanomaterials and nano devices, and which could be used for the various applications. So these features will include to produce products and production processes with better characteristics and functionality. In the first and second industrial revolution, many industries were set up. They were said as silly. It was said that big was beautiful. Now in the third and fourth industrial revolution, because I don't want to differentiate between the third and fourth industrial revolution, because the third industrial revolution is nothing but the continuation of the fourth industrial revolution. In this fourth industrial revolution, the small is not only the beautiful, it is wonderful and also the powerful. And this science of miniature of science and the technology of the future is one of the most exciting and wide area of research in any fields of basic science or even in the applied science as well as in the engineering field, leading to many greatest technological advances in this 21st century. This technological advancement is expected to pave way for revolution in materials and going to redesign the future of most of the existing technologies, and also expected to bring disruption in most of the products as well as in the market, particularly in the consumer market. Now, if you look at the nanomaterials, if you look at novel exploitation of these phenomena and properties of matter at nanoscale, basically it is nothing but, the nano is nothing but billions of a meter. Like if you take one sheet of paper, just to give an example, it is something like 100,000 nanometers. And imagine the 1 nanometer size, which is the atomic or molecular size actually, and which has, when we make into a smaller and smaller, like for example, the gold at the bulk looks different in terms of the color, in terms of the optical properties, in terms of the thermal properties, and so on. When the gold is made into a atom level, atom scale and molecular scale, the entire property changes, and these properties will be used in many of the applications, like for example, materials and manufacturing, like automobiles, machines, electronics, computers, telecommunications, information technologies, medicines, drugs, healthcare, genetics, biotechnology, devices, and so on, and also even in the clean energy and the environment, defense and security, chemical and biological technologies, fabric, cosmetics, surface and surface coatings like paints, and even in the agriculture and development of even many sensors. I just only have given a few examples. It is going to touch on every aspect of the human life, particularly in the applications, make it the small as the more powerful in the coming years. And now many of the applications have gone from the lab to a field, but large number of applications are expected in the coming years. In fact, nanotechnology today, in many of the countries, it's in the infant stage, and maybe in the next 1 or 2 decades, certainly it is going to play a major role in the development of many applications the way we are seeing today in the industry, particularly in the field of computers and electronics. If you look at the nanotechnology, it's a knowledge-intensive and enabled technology which requires the multidisciplinary expertise, multidisciplinary, and even actually the different sub-disciplines expertise. In fact, it is not just one subject. It requires physics, chemistry, material sciences, to play at science level, to study the phenomena. Once that is being done, the biologists, the biochemistry will use actually for various applications like sensor development in agriculture or a precision agriculture or biomedical related things and biotechnology related aspects. While engineers involved in the product development, production process with better characteristics, how best it could be product could be developed, commercialized, is the part of the engineer. Today, although the nanotechnology research and development in India started from the beginning of this millennium, a greater emphasis was given from 2007 with the participation of many of the Government of India organizations, namely the Department of the Science and Technology, the Department of Electronics and Information Technology, the Defense Research and Development Organizations, Council of Scientific and Industrial Organizations, Industrial Research, Department of Biotechnology. With these organizations, actually, they've established a large number of characterization facilities, fabrication facilities across the country in various premier research institutions in the country. For example, that most of these facilities have been established for basic research, particularly in the field of nanotechnology, both in the basic sciences, applied sciences, as well as in the engineering field. And also, a large number of infrastructures have been established for carrying out the front-ranking research in many of these places, and also the development of nanotechnologies, and how best these nanotechnologies could be used for the varied applications, starting from the agriculture to the even the health and medical care and so on. And the most important thing for any of these developments is a skilled manpower. And I must say, as I said, most multidisciplinary, this human resources is the most important actually in the field of nanotechnology. And of course, this also involves actually the infrastructure capital investment is very huge. There's a reason actually many of the nanotechnology institutions, nanotechnology facilities have been established in some of the premier research institutions. In fact, they have the best state-of-the-art infrastructure. Like in Bangalore being the IT capital of India, biotechnology capital of India, the science capital of India, we have a large number of premier institutions like Indian Institute of Science, Jawaharlal Nehru Center for Advanced Scientific Research. We have the National Center for Biological Sciences and various the Indian Space Research Organization. Several central government, state government institutions are in the Bangalore. They are one of the best institutions in this part of Asia. And also, they have been involved in the development of the human resources as well as the skill development using these facilities which have been established by various governments, the departments of India. And also, we have been having large number of national and international collaborations, particularly in the field of nanotechnology. In fact, as the moderator said, actually, we have a large number of MOUs with various national organizations, including ASEAN governments and various other European countries, as well as USA and many other Asian countries. Considering the societal benefits and fastest growing economy in the field of nanotechnology, we have not only established infrastructure facilities, we have also established large number of educational institutions in many of these premier institutions in the country to have outstanding knowledge of nanoscience and nanotechnology in combination with skill set development in many of these institutions. Two of the state-of-the nanoelectronics, nanofabrication institutes. One is in the Bangalore, right in this venue, the Indian Institute of Science, and the other one is actually the Indian Institute of Technology, Mumbai. And in fact, these facilities could be used by many of these research scholars, the scientists, the academicians, and so on, even the startup companies. In fact, Indian Institute of Science has a wonderful facility for development of the startup. In fact, they have a wonderful plug-and-play facility for many of these startups to come and use their facilities, come and use these facilities for a certain period of time. Then they can independently take up their own startup companies with a big establishment. In fact, we also have a large number of institutions. There's one important institution I would like to mention, that the International Advanced Research Center for Powder and Metallurgy and New Materials, ARC, which is in the Hyderabad. It is also one of the premier organizations in the field of nanomaterials, and it has been doing a wonderful job. In fact, in addition to that, the government of India at the national level has established almost 12 units of nanoscience facilities so that various users at different locations in the country could use these facilities. And we also have 7 centers for nanotechnology, which have been established by the government of India. In addition to that, very specific institutes dealing mainly on the providing education mainly on the nanotechnology have been established in the country. One of the premier institutions is the Institute of Nanoscience and Nanotechnology, which is there in the Punjab. It's another state in the federal country, which is doing actually extremely a good job in graduating, particularly the post-graduation and producing PhDs. It was established in 2013. We have another institution in Bangalore that is going to be in the Bangalore. And in addition to that, we have a large number of programs at the state level guided by the Indian Icon of Science, Professor C.N.R. Rao, and with policy makers and the academicians. They guide us actually in development of a nanotechnology in the state, and we have a large number of programs in the field of nanotechnology. One of the programs the government of India has been doing it to bring a global platform for the academicians, the researchers, the policy makers, and also the venture capitalists, and as well as the administrators. We organize every year an international event, a nano conference. Bangalore, it's called Bangalore India Nano Event, and it's been organized since from 2007 onwards. Very recently, we organized the decennial celebration. The next year, we are going to have the 11th Bangalore India Nano. In fact, it is going to be the radar of many countries. Large number of the best experts in the country as well as international speakers are being invited to this actually. And I would like to, invite the Australian delegates to come and join us for this our nano event, which is going to be scheduled from March to 2nd to 4th in Bangalore. And with this, actually, I would like to say that and conclude that actually nanotechnology is going to be a fastest growing research area, where it is growing something like 17% the cumulative average growth rate, and by 2024 it is expected to yield something like revenue of 125 billion. There is an infinite area for development, and slowly the research is yielding into the technology. I'm sure the coming years will be a wonderful opportunity to work in this nano field. With these few words, I would like to close my presentation. The next presenter is actually Mr. Siddhalingaya. He is going to speak on nanotechnology in precision agriculture. Now I call upon Mr. Siddhalingaya, please.
Profit is the purpose of any business. Similarly, finding right purpose in the life is very important for each of us. Can profit and purpose go together? Yes, it's possible in sustainable agriculture. Good afternoon all. Dr. Robert Look, Dr. H. Honegodaji, Dr. Venkatesh, Professor Sanjit Ji, Dr. Govind Raju, Sampath Kumar Ji, and ladies and gentlemen, a warm welcome. I am very happy to share some of my work towards agriculture. Now, in this session, I'm going to cover two things. One, about my startup company, Precision Farmers Bangalore, some of the solutions what we have developed. In the next part two, I'm going to talk about smart sensors, which are very much needed for agriculture aspect, which are nanotechnology or microtechnology based. For those of you who are not from farming background, I would like to give just a quick introduction in a minute or two. Agriculture, the history traces back to ancient civilization. We can see some of the agriculture related work from Indus Valley civilization, Egyptian, Chinese, so many things. And agriculture is one of the most ancient profession which is sustainable, and that has to be there so long civilization exists. Now, we have seen technology making intervention everywhere. In the past 15 years, I am in the industry. I had an opportunity to work with aerospace, defense, consumer electronics, automobiles, many things. One key thing, wherever technology has intervened, it has made significant amount of transformation. If that is the case, we know climate change, agriculture, not only in Asian countries, even abroad also, there is a need of agriculture to meet a growing need of food. Next soon we are going to be 10 billion. In that case, Indian context, some of the key challenges what we are going through: labor, water across world, poor yield. Unlike US and European countries, we have small and marginal farmers in India, lack of technology, and most importantly, shrinking arable land area, whereas population isn't there. How do we meet the demand? That is the question. That made me to think about something in precision agriculture, coming from farming background. This is the overall architecture. The technology what we have developed has got 3 stages. In the first stage, we have deployed sensors in the field for monitoring data. In the second, the data is pushed onto the cloud using wireless technologies where the analysis is done. In the final stage, by analyzing this data, actions are taken. So this is used for both open field, which is close to 85–90%, and about 5% of protected cultivation. That also includes horticulture. The whole idea, what we wanted to achieve here, connected farms. Now the world is talking about Internet of Things, connected vehicles, artificial intelligence, many things. In that case, can we not bring all farms together as a connected farms? This was the first prototype which we deployed in the open field. You can see in the picture, papaya farm is there. You see small nodes which are wireless. Each of these nodes have sensors for monitoring soil parameters. We started with moisture sensing. Moisture sensors are deployed at different places in the same field. The data is aggregated through one main unit, which you call it as aggregator. The data is pushed onto the cloud. You can see in the bottom, real-time data every half an hour, 1 hour, which is programmable. M stands for moisture. I have divided them into 3 zones. Yellow means there is a less water. Green is normal water. We don't have to take any action. The red one, there is excess water. We need to switch off. Then after doing one full cycle of this experiment, we wanted to further fine-tune our product. That's when we moved on to protected cultivation. Protected cultivation, which is grown under any structures. It could be greenhouses polyhouses, or for that matter even horticultures. You can see in the picture, in the same polyhouse, which was about 1 acre of land, half hectare, 6 crops were cultivated. This experiment was done in University of Agriculture Sciences, Dharwad, which is in Karnataka state. Each individual crops had independent walls. We gathered data, physical data of earlier only moisture sensing was done. In this case, we added additional parameters. In addition to moisture, temperature, relative humidity, light, weather conditions were observed. The data was collected at cloud. The whole objective was to give optimal conditions for the plant growth, which gives best yield. And as a result, we controlled irrigation valves and manually ventilators and curtains were moved on. You can see on the right side, mobile app. Using mobile app, we were monitoring all these parameters every half an hour. In the next stage, this was way back in 2015-16, we observed few challenges. Then we installed the system right at the beginning. This project was done in University of Agriculture Science, Bangalore, which is close to IISc here. The comparison was done between open field and the greenhouses. On the left side, you can see there are 2 polyhouses which are even more sophisticated. In addition to moisture, we also took care of ventilators, light movement, and also other parameters. In addition to the sensors what we were measuring, we also deployed some reference sensors for optimizing the parameters. Finally, the comparison was done for 2 crops. One was broccoli and other one was cucumber. We could see a significant improvement in the yield as well as quality. At the same time, we were able to reduce cost of operation, fertilizers as well as water. So this is the key message what we wanted to bring it to the farmers. Just because we give more water and nutrients, we will not get best result. We get best result when optimal conditions are given. And all these technologies is for rural or suburban. Can we not think of some methods for urban farming? That's where we thought of working indoor farming. In the picture you can see we designed a small structure which was completely deployed inside a home indoor. The grow lights were used for stimulating plants photosynthesis. Photosynthesis is active only in 2 regions, green and blue, red and blue. Okay. So the exact combination of light was given for the plant growth. We could see a good improvements here also. Although this is far-fetched, this is a way towards vertical farming. Overall, we were able to do successful testing for open field as well as a protected cultivation. In the next section, as I mentioned in the part 2, one of the greatest challenge what we thought, what we faced was cost of entire setup. The entire system was about 50-60,000, which a normal farmer will not be able to offer. When we had a close look at the system, sensors was something which was taking significant amount of cost, close to 70-80%. That's when we thought, can we develop some smart sensors? Here, unlike other fields, all these sensors needs to be deployed in a very harsh conditions, remote locations, where I don't have regular power supply. That's where my attention moved towards microtechnology and nanotechnology. For those of you who are aware of traditional farming, high-tech farming is also one more sector. We also call it as soilless cultivation. Yes, it's possible to grow plants without soil. See, some of the three techniques here, what I mentioned: hydroponics, wherein plants are grown in water. Water is circulated, nutrients are added, we are able to do it. Lettuce, capsicum, many crops are grown. Aeroponics, it is done for potato and many other crops. In this case, roots are hanging in the air. Water and nutrients are sprayed at certain intervals. Plants are able to grow. And the third one is aquaponics, which is a combination of pisciculture plus my regular. In this case, a symbiosis effect is happening. You can see all these are needs a regular monitor of various parameters. These are the parameters what I want to measure in agriculture. One is physical parameters, which is moisture, temperature, humidity, organic carbon, and many others. When it comes to chemical parameters like primary macronutrients, nitrogen, phosphorus, potassium, secondary nutrients, and also micronutrients. In addition to this, gas sensing is needed, carbon dioxide and other nitrous oxide in protected cultivation. And most importantly, chlorophyll. Just like hemoglobin plays a very important role in human beings, a chlorophyll plays important role in plants. So we wanted sensors for all these things. Do I have them in the market? No. We have only few sensors, but there is a huge scope for developing these sensors. For the sake of easy, I have segregated all the sensors into 4 broad divisions. One is physical sensors, which I already mentioned: moisture, temperature, light, pressure, weather related things. Second one is chemical sensors, that involves primary and secondary nutrients, macronutrients. Okay. Third one, mechanical sensors, level sensing of water, location sensing, speed of flow, how much volume of fertilizer or water is consumed, angle, and many. Some of these play important role in robotics. Now AI robotics is getting into agriculture. People are working on developing robots for harvesters, spraying. That's where these mechanical sensors are very important for precise movement. And the last one, biological sensors. Yes, it is possible to prevent pest disease even without using chemicals. This is the one more area where a lot of scope is there. To sum it up, when I started my startup company 5 years back, challenges were aplenty, but still the journey is very much rewarding. Today, I have an opportunity to work with one of the biggest company, global company, Mahindra, which is very much interested in our technology and supporting us in many activities. And second one, as I mentioned, my journey towards developing these smart sensors will continue. That way, I have a close relationship with IISc. We have already developed a moisture sensor, which is very cost effective. Unfortunately, I will not be able to share more details as they are IP related, but the potential is there for developing other sensors. So my final words: this is a noble cause, and agriculture is going to stay here so long civilization exists. So let's come together to work for this field that can give health, happiness, and hope for the entire civilization. Thank you so much. Now I would like to call upon Professor Prasenjit to take forward. Thank you so much.
Okay. Good morning, everyone in Austria, and good afternoon to all who are joining from India. I am Prasenjit Sen from Center for Nanoscience and Engineering in Indian Institute of Science, and I am happy to present this webinar on behalf of my department. And I would like to first let you know that that we have signed an MOU between Indian Institute of Science and Australian Institute of Technology, and that will probably help in increasing collaborative research in future. So before I go into the topic of nanotechnology in medicine and pharma, I would like to give you an overview of our center, which is a premier center looking into research in nanoscience and engineering. So the vision for Center for Nanoscience and Engineering germinated in year 2000, and after that there was a lot of discussions with the government to fund this department. And in year 2002, Principal Scientific Advisor to the Government of India actually took initiative and pushed this process so that a National Nanoelectronics Initiative was launched. In year 2003, ISC Bangalore and IIT Bombay were identified as the leading organizations for setting up these two centers for excellence in nanoelectronics, and funding was allocated in year 2005. In year 2010, the department was born and the work started. So this was a completely greenfield project. The institute helped in providing the building, and the government provided funding in form of populating the building with various different kinds of facilities, which I will show in the next slide. So in sense, we host a wide range of facilities which allows us to work in the domain of nanotechnology, ranging from design to final packaging and system development. One of the main facilities in this is a 14,000 square feet clean room for nanofabrication of devices. The clean room is class 100 and class 1000. In this, we have comprehensive capabilities of doing micro and nano fabrication with various different capabilities. We have our lithography capabilities allows us to go to the scales of 10 nanometers. In addition, we have various different kinds of deposition and etching technologies available at the facility. We also do in-house equipment development for developing equipments and processes which are currently not available in the market. We also have a comprehensive characterization facility, which is again one of the kind in the world where there are different kinds of characterization tools and equipment housed under a single facility and allows external users to access and use this facility. In addition, we have MEMS and IC packaging facilities, which allows us not only to work till the level of technology demonstrators, but also look into the fact that these devices that have been developed in these other facilities can be packaged and made useful for external users and industry. We also have a facility for system engineering, which allows us to look into development of the systems that will allow the device to become a complete product. In addition to these centralized facilities, there are other facilities which there are other laboratories which looks into research in various different kinds. This is international benchmarking. We have benchmarked our facilities against several international experts, and their view is that this is the facility available here is comparable to anywhere in the rest of the world. This is sense in numbers. We have a faculty strength of 12 regular faculty, 5 emeritus faculty, of total of 17. We work with 135 PhD and MTech students. We have a large technical staff which takes care of all the centralized facility. We have admin staff to support all our activities. And our achievements in numbers in terms of publications and patents are shown below. As you can see, we do focus a lot on patents, and that has been our we do focus a lot on patents, which is visible from the number of patents that you can see. So if I want to talk about what is the theme of the department, or what does the department think about when it decides to select the problems that it wants to tackle, we look into science to systems, and the aim is for societal impact. We have, being an interdisciplinary department, we have various faculty from science background who look into discovery of new phenomena. We have faculty who are working in the engineering domain who take these discoveries and through their innovation turn them into viable product demonstrators. And then we have various faculty and facility technologists and staff who are looking into the technology aspects and the systems aspect to make the product demonstrators into final products. We also work towards our national agendas, which are national programs run by the Government of India. So now I would like to discuss some of the successful products that have come from SENS. So one of the products that has been successful from SENS is pressure sensors for aerospace industry. This work has been done by Professor K.N. Bhatt and Professor M.M. Nayak. And to emphasize that this work started all the way from the design of the pressure sensors, fabrication of the pressure sensors on silicon wafers, and then packaging of these pressure sensors onto aerospace compatible packages, and also system assembly so that they can be actually deployed in helicopters and aircrafts. Currently, there have been 30 pressure sensors which have been delivered to the helicopter division of HAL Bangalore, and these are being qualified for different applications. Again, this is another product. This is a mobile diagnostic lab for bridging the healthcare divide, first of its kind in the world. And the project was started by Professor Navkant Bhatt, and he started the project by looking into the fact that within the last decade, diabetes has become a significant problem in India. And for management of diabetes, currently the tools that are available only looks into the blood glucose level. If we talk to the clinicians and doctors, what is happening in the medical science today is that the instantaneous glucose level is no more considered as a gold standard of measuring what is the status of the diabetes. What they want to look into is a parameter known as HbA1c. Now, measurement of HbA1c requires complicated equipment. So he decided that if he can make a strip-based system which can look into HbA1c, then that would be beneficial for deployment in rural areas in India. So that is how this work started. And when they ended up actually developing a platform which not only measures the blood glucose level or the 15-day average of blood glucose level, which is HbA1c, but also measures various other parameters, actually 8 other parameters, which look into various other complications that might arise due to diabetes. So that is why it is truly a mobile diagnostic lab on a device which is in the size of a tablet or an iPad that is available today. This company has been incubated. Its name is Patshod, and they are currently testing the product in various different locations. Again, one of the major issues in this area of nanotechnology is regarding the cost of the equipment that is required for manufacturing these devices. Now, with this aim and the aim of actually looking into better indigenized equipment, one of the faculty, Professor Srinivasan Raghavan from SENS, in collaboration with a company called CAS Technologies, developed a graphene CVD reactor. And this is a commercial product now, and they are selling the product through CAS Technologies. In addition to the other products that I have discussed, there are several others. One of them has been developed for internal use at IG car. It's a neutron sensor. We have developed gas sensors, which have been delivered for various different purposes to different organizations who are looking for specific gas leakages or for monitoring of environment in the roads and various public places. There has been development of soil moisture sensors and flow cytometer. In addition to a work that has been going on in our facility by us, what we realized is that this kind of facility is not built easily and is not easy to duplicate in multiple locations in a country like India. So government decided to fund us to actually support people or students and researchers from various different organizations all across India to come and use the facilities to do their research. We have 703 organizations have actually availed of this program. We have conducted many workshops and hands-on training projects, and there have been 700 research projects which have been conducted through this program, and the external users have been able to file 37 patents and have multiple number of publications, and approximately 400 theses, PhD theses have been supported through this program. Another program that is being hosted by the department is called iSTEM. The idea here is that this area of research and requires equipment which are not only expensive, but also very difficult to maintain and run. Hence, developing a list of all the available equipment in the country and bringing them under one umbrella allows different users to figure out where the equipment are and how they can use it. We have multiple different collaborations with multiple international universities, as you can see in this slide. In addition to academic collaboration, we also have collaboration with multiple different industries, and some of these industries actually decide to become our affiliate members. And this is the list of the industries which are currently our affiliate members. Again, to highlight the startups that have come from Sense, we have Pachod, we have GT Silicon, Cura, and I2N Technologies. Again, to iterate, focus at Sense is to develop deep science and technology-based startups. Recently, Government of Karnataka has supported us to house a technology business incubation program. Under this program, we will be supporting 25 startups in the nanotechnology area over the next 5 years. So before I actually go into the part of where I talk about nanotechnology in medicine and pharma, I would like to give you an overview of the research focus at Sense. What are the different kinds of research that is happening at Sense? So there's a big group which is looking into GaN power electronics. GaN-based, gallium nitride-based power electronic devices are powering a lot of mobile chargers, laptop chargers today, and their use is expected to become larger and larger. Again, here, like what I talked before about the pressure sensor, our work starts from material deposition. So we do grow our gallium nitride here, and then we take it all the way from device manufacturing to packaging and system integration to actually demonstrate DC-DC converters. We have also been looking into emerging electronics area, where the research is focused on 2D materials, newer type of oxide electronics, and other areas. There is a large initiative in the area of photonics, where the primary focus is towards looking into chip-to-chip communication, replacing several current computational, components using optical components. We do have a large initiative in nano, bio, and healthcare, but that I would describe in the next slides. We do have photovoltaics and energy devices, where we are looking into solar cells and energy harvesting devices. But again, the perspective is from the social impact, where we are looking into developing photovoltaics on steel, which would allow us to put them in various structures to power multiple homes. We again have a big initiative in nano, agri, food, and environment, where we are looking into various kinds of sensors and other devices. To sum up all this, we also have an initiative in 3D system scaling. The idea here is that if we think about current systems and how current systems are developing, there is a focus towards developing systems which are do not conform to the pre-existing form of systems, such as a laptop or a desktop computer. Today, we are looking into more of flexible devices. We are looking into implantable devices. We are looking into edible devices. So all these devices can be formed by actually tightly integrating various different kinds of devices in a single chip and that will allow the systems to be scaled further than what is currently possible. So this initiative in 3D system scaling is looking at scaling of systems through heterogeneous integration. Now I come to the part of nanotechnology in medicine and pharma. In this part, what I will do is I will talk about some of the research threads that are going on in the department in this area. So we have been looking into interfacial micro and nanofluidics, and as we all know, micro and nanofluidics is one of the basics of doing what is known as lab on a chip. The idea of lab on a chip is basically to take what a conventional lab would do in terms of biochemical analysis and try to do the same biochemical analysis on a single chip so that it can become portable. Once it becomes portable, this kind of diagnosis or biochemical analysis can be taken to rural areas or hard to reach areas, and healthcare can become more pervasive. So in this part, the research has been mostly to talk about what are the fundamental problems in terms of physics of the fluids and their interaction with surfaces. So based on that fundamental study, this would allow us to develop what is known as a biosensing platform. Here we are looking into development of a multimodal biosensing platform. And the objective of this work has been that if we look into cells today, right, when we analyze cells through a cytometer, the cytometer would give the properties in terms of electrical measurements and optical measurements from the cells. The optical measurement mostly looks into a biochemical response of the cell to a very specific tag that the cell has been exposed to. Recently, what people have also realized that in addition to this biochemical signals and the electrical signals that the cells provide, the cells are also like a mechanical element. They have stiffness and they have viscosity. Both of these properties actually provide a significant insight into their condition. It has been proven that under certain disease conditions, these mechanical properties go through a very well-defined change. And the ability to measure such a change in the mechanical properties of the cells will be beneficial for clinical settings. Hence, the work is looking at developing a platform which will simultaneously measure electrical, optical, and mechanical properties of individual cells and look into their correlation to figure out what disease state this cell is probably in. Again, when we are studying cells, we have developed a unique technology to figure out their mechanical properties. The conventional way of measuring the cell's mechanical properties uses AFM tips, but those tips can be very harsh for a soft cell, and hence we ask the question, can we figure out the cell's mechanical property by squeezing it using an air-liquid interface? And we have shown that it is possible. We have been able to squeeze them to sub-micron sizes. We are able to measure the elasticity of each cell, and we can also introduce chemicals to see their effect on the cells using this technology. Another problem that the center has been looking to tackle is what is known as multi-drug resistant bacteria. This multi-drug resistant bacteria is becoming a big problem in the medical world. These bacteria do spread from various surfaces from one patient to another. Being multi-drug resistant, they are very difficult to treat. Hence, one of the solutions that has been proposed is that why don't we make the surfaces antimicrobial in nature? If the surface doesn't allow the bacteria to grow on it, then the transfer of the bacteria from that surface to another person, from one person to another through a surface becomes not possible. In recent times, what has been shown is that if a surface is structured, or if it is provided with nanostructures, then such surfaces can effectively repel bacteria and also kill bacteria when they come and sit on the surfaces. This is something that you can see on the right-hand side, bottom right-hand side of the picture. Now, one of the problems of making this nanostructured surfaces is most of the techniques that we know to make nanostructured surfaces are expensive. And what we need is a large technology which will allow us to cover a large area, which is flexible because that will allow it to conform to various different kinds of shapes. And such a technology has been developed based on PDMS and copper hydroxide nanowires. The processing technology has been optimized, and such surfaces actually have been tested in a hospital environment for their effectiveness. And they have shown that they are effective in killing a multiple variety of multi-drug resistant bacteria which are captured from patients in the hospital. So what could be the healthcare applications? Some of the healthcare applications that we have thought about is not only hospital surfaces like doorknobs or bed rails, but they can also be used in stethoscope surfaces, otoscope surfaces, and gloves and aprons, which can be coated with such a antibacterial surface. Now, this work is done by Professor Akshay Naik, and the question that he is trying to ask is, what is the weight of a single protein? And such a study is important, or such a device is important, because that allows you to correlate or look into an unknown sample and try to find out what proteins are present in what quantity. Now, developing devices or MEMS or NEMS devices which can actually measure mass of a single protein requires to scale the device down to the nanometer scale. And what he has been able to do is actually develop nanometer scale devices which can very accurately measure what is the mass of a single protein. This work is done by Professor Amrish Ghosh, and he has been a pioneer in this area where he has developed nano swimmers. So to give a little background, when things scale down, when things become small, it becomes very difficult for them to swim. They cannot swim the same way in any liquid. They cannot swim the same way as we swim. And that is because in a low Reynolds number regime, things are reversible. So to swim in a nanoscale, you need to have structures which look like flagella of a bacteria. And that he is able to develop. He has a unique process to make this helical structures, which he also calls nanoscrews. And these helical structures can be moved in a fluid by external rotating magnetic fields. Now, the question is, why do we want to do this? So there are many different applications. One of the major application that a lot of the world is looking into is to take the drug towards the tumor. Right? So in cancer, most of the therapy currently uses drug which is dispersed all over the body, and the drug harms a lot of different parts of the body where it doesn't need to actually act. So targeted drug delivery, where the drug can be taken directly to the tumor and released there, has been a dream of this community, and he has been working towards this goal. In addition to this, what he has shown is that these nanoswimmers can be used as a probe to study the intracellular biophysics. Based on the same nanoswimmer, what he has also demonstrated that he can actually move micro and nanoscale particles. So one of the techniques of moving nanoscale particles in fluids is known as a light tweezer, but optical tweezer. But the problem with the optical tweezer is, as the size of the particle becomes smaller and smaller, the intensity of the light that is required to trap the particle and to move them becomes larger and larger. And hence, if optical tweezers are to be used with smaller living species like cells or bacteria, the high intensity of the light will have a tendency to damage them. What he has been able to demonstrate is that by using a nanoswimmer, in addition to a plasmonic tweezer, he can obtain this operation of moving micro and submicron nanoscale particles with relative ease. And this is a picture from one of the videos where it shows that he can actually transport living bacteria inside microfluidic chambers. Now, this work is done by Professor Manoj Verma, who is another faculty at the center. And the question that he wants to answer is, can protein sensing be done using nanopores? And even though nanopore technology has been proposed for some time and has been in use, it is still requires a significant amount of work to reach where it is and needs to go. So they have been able to fabricate nanopores at our center, where you are seeing pores, all the dimension on the top at 30 nanometer, and on the bottom, the pore diameter reduces to all the way to 5 to 6 nanometers. And using this, he has been able to detect and size gold nanoparticles. He has been able to distinguish between gold nanoparticles of 5 nanometers, 10 nanometers, and 20 nanometers. Again, by functionalizing the nanopore using an aptamer which is specific to thrombin, he has been able to show that once thrombin starts passing through this nanopores, because of its specific adhesion or specific interaction with the aptamer, it takes a much longer time for thrombin to pass than streptavidin, which is again a comparable size, because that specific interaction is not there. So with this, I come to an end to my part of the presentation, and I would like to invite Professor Govindaraju to come and continue with the discussion.
Thank you, Prasenjit. Good afternoon, Bangalore, Delhi, and good morning to Austria. Let me, at the first outset, let me thank Austrian Trade Commission and DST, Department of Science and Technology, Karnataka, particularly Dr. Onnegowda for the invite. Let me start by saying, small is big. So Dr. Onnegowda mentioned about, the big is wonderful, and then, also said the small, is actually wonderful and beautiful, so on and so forth. I would also say that small is, indeed, is big, wonderful, beautiful, and it is so true in case of nano, particularly nanoscience and technology. Today, so I'm going to present you in this webinar. I'm going to present to you in my views on the current status of translation, nanotechnology translation in India. I also give a perspective of both global and India perspective at this stage. When we talk about a translation, I would like to, to start with, mentioning so the nanotechnology is still, is not a, in terms of translation, nanotechnology is not a mature, is not fully mature like other technologies. So nevertheless, there is a lot of opportunities, and there are two kinds of, streams I'm going to mention to you. There is a research, there is innovations which are not being translated, but it has the potential to translate. And there are already, innovations which have been already, undergoing translation. So nanoscience and technology is all about creating nanomaterials or fabricating nanomaterials through either top-down approach or a bottom-up approach with newer properties at nanoscale. To simplify, when I say top-down approach and a bottom-up approach, it can be chiseling down or a stacking of things here are atoms and molecules. So in terms of, one of the well-known domain of this nanotechnology is carbon nanotechnology, which include carbon nanotube, graphene, carbon, fullerenes, and so on and so forth, which is kind of, mostly matured area within the domain of nanotechnology. And there is, analogous domain of inorganic nanostructures. In addition to that, there is something called nanobiotechnology, or also molecular architectonics, which some of the, architectonic concept was introduced by us, which talk about using biomolecules to build up, materials, nanomaterials. So having all this together, it's made it possible to produce novel materials with novel properties, and if you use it correctly and properly, has the power to influence every spheres of our lives. In principle, I would emphasize every spheres of our life, which can kind of cross across the domains of health, energy, environment, and so on and so forth. And thanks to my other colleagues, we have talked about many of these aspects. Particularly, there are many startups in India and also across the globe in terms of energy, producing renewable energy, clean energy, and so on and so forth, which I'm not going to touch upon. But I'm going to give few examples, in the domain of health. Particularly, I would like to mention water management, particularly providing clean water. I would like to kind of draw your attention. One of the startup from Indian Institute of Technology, Madras, which is actually now graduated, started by Professor Pradeep. So it's a wonderful example of using nanotechnology for water purification. And there you also already heard about agriculture, from Siddhalangaya. And I would be bullish, or even I would bet mostly when it comes to translating nanotechnology, I would bet on sensors and diagnostic at this moment. When it comes to treatment, probably we may have to wait for a while, but nevertheless, there are a lot of things are happening, and especially, happening. And one of the area which has got benefited early on was cosmetics, which has, already nanotechnology is playing a big role in the field of cosmetics. And also probably I'll touch upon a little bit on environment. Nevertheless, there are also startups in India which are, doing wonderfully well in terms of, for example, carbon dioxide capture and converting into useful materials. So these are some of the, so I mentioned to you, so it can play a wonderful role indeed, and then nanobiotechnology indeed, will play a big role in our daily life, from health, energy, environment, and even nanomedicine. So in terms of nanotechnology market, so I would mention serious research has started sometime in 1980s or 1990s. So, and then suddenly, because the nature of this area itself, draw the attention of applied research, they're also, kind of by already, within the next 10 years or a decade, so people also start looking into applied research. And then now we are seeing a rapid development of this nanotechnology. And there are also some of these, kind of translation is happening. But what, in the next 10 years, probably we'll be looking for mass market, taking these, innovations probably through startup to a mass markets. And it is expected, but as of 2019, it is expected that the nanotechnology market is 65 billion, roughly around 65 billion. However, most of this market is captured by mostly nanomaterials and nano tools. So not much is happening in terms of nano devices and applications. Prasanjit has talked about, a lot of devices. That is something, all of us are looking forward to in the coming decades. So this is just a passing note. So nanotechnology is ubiquitous in nature, around us and within us. So that means nanotechnology can indeed inspire developing nanomaterials. At the same time, it can also inspire translating them for real life applications, including nanomedicine. So most of the, as I mentioned early on, so the most of the research in the nanotechnology, advanced research happens in the academic labs as of now. And in that sense, because of, it's still not matured enough, in terms of translation. So in that sense, academic, or a research, basic research, labs, going to play a big role in terms of, coming up with new and emerging technologies. And there should, need a constant interaction between industry and academia. And I would actually, urge, I would urge, and also, kind of a bet too much, a lot on academic, people, academic research to, take their innovations to the market through startups. So just to, for example, I already mentioned there is, kind of nature can inspire us. You can see that there is a, kind of, we have a microtubules where the, vesicles has been transported, and this has inspired, development of lot of molecular machines and devices, which is again inspired by this. People have come up with the nanoboards. Prasanjit has already mentioned about nanoboards here and also elsewhere, for which can be used for diagnostic and delivery application. And there is a lot of things are happening in terms of startup, in terms of wearable devices and textiles, which is again for energy harvesting and health monitoring and so on and so forth, and which has a lot of potential. And as of now, kind of, for example, I mentioned a technology which are at the edge of translation but still not translated. What are those technologies? For example, recently a group has kind of come up with an idea of infrared vision, introducing infrared vision for in a mice by injecting nanoparticles into their eyes. it has a very wonderful, kind of a potential. Well, and I also have come across a very crazy idea, a crazy startup. I like it actually, from Mumbai. We all know that there is a global army and there is also trust, which creates actually, our brain gets heats up. So just like we have a AC and a fan, what would you do about it? So this particular startup, it's called Atom Technologies in Mumbai. They're thinking about something called nanofan. So it's it's something probably it could be literally a disruptive idea. So this is something this greatness about nanotechnology. So from India perspective, India has a very good standing in terms of global. India has a very good global standing thanks to Government of India, particularly Nano Mission headed by Professor C.N.R. Rao, who also happens to be in our institute, Jawaharlal Nehru Center, and thanks to him, so now India stands at third or fourth, one of the third or fourth countries in terms of research output. If not all of this research, some of this research can be translated into products. So again, thanks to it's already been happening. Thanks to Startup India, Make in India, and also very, very strong support from Karnataka government, and very true in Bangalore. Bangalore is the epicenter for science and also nanotechnology, and is also for and so is for startup. So I mentioned about basic science, translating basic science into translating basic science. Well, in doing so, we need not to differentiate between basic research and applied research. I think this is where we need to come out of these kind of domains. And doing so, while we are doing basic research, we need to identify some of these potential technologies wherein we think about simplification, reproducibility, standardization, scale up, and also cost and marketing we need to look into. And in doing so, probably we can translate. I'll give you some of our own example. For example, we developed a solution-based self-cleaning nanomaterial, which can actually kind of coat any surface through a solution processing, which is very, very easy, which has a very good translation potential. And we also developed recently a biomolecules based biomaterial based conducting material. For example, you all heard of silk, you all heard of melanin, which is there in our skin. By making composite, we can actually make it a conducting material, which has lots of applications in regenerative medicine and also bioelectronics, which we are also thinking kind of taking into thinking about translation of some of these aspects. Just to let me give an example, one more example, how we can actually simplify a complicated research, basic science which can lead to translation. We all heard about DNA nanotechnology, which is every day we see publications coming in very high impact in papers. But when we talk about applications, people are skeptical. Of course, except storage, it is still people are skeptical. In this context, we come across a templated DNA nanotechnology concept wherein you use a very short DNA sequences, which is commercially available, and we template around a small molecules, which is a functional molecule, and then you have a nano system which are actually useful. Very, very useful. You can actually make, you can make a, a device out of it. You can make a FET devices, or you can make these using these nano particles or a nano system. You can make kind of a surface enhanced resonance based platforms and so on and so forth. And in fact, using such platform, we have come up with a device wherein we can actually detect mercury with a ultra molar sensitivity, which is the highest sensitivity possible, and which we are taking forward for translation through our startup, Veneer Biotechnologies Private Limited. Probably I'll take a minute or so to tell you a little bit about this startup, which is a deep science project, a spin-off from Jawaharlal Nehru Center, Center for Advanced Scientific Research in Bangalore, to commercialize some of the innovations from our own laboratory. So we have 3 or 4 portfolios, but I will just take one example. I already mentioned one of the portfolio, and I will mention another one which probably interests you most of many of you. For example, so we are coming up with a common diagnostic platform for DNA liquid biopsy, which is based on DNA nanotech. Both DNA nanotechnology or simply a nanotechnology platform. This is all about DNA capture, detection, quantification. So what is the use of it? We all know that when a cell under a stress condition or when there is a cell death happens, so the DNA which is wrapped around histones can actually fragment and then released into the plasma. So these are a DNA fragment, which are around 100 to 200 base pairs, and very, very small compared to a big genomic DNA. So currently, whenever people start analyzing, they're looking at the genomic DNA. However, these fragments of DNA, which you see in the plasma, we call them cell-free DNA, holds most of this information, responsible, for, they can act as a biomarkers for detection of many disease, and particularly so for cancers. So in fact, now we are we are developing, there are some products available in the market, but they are not selective, and then, it's very difficult to quantify, and, because of their, non-specificity, cost, and so on and so forth. But here we are going to develop a cost-effective, very, very selective, platform, which is going to be a common platform to detect most of, not just one cancer type, but all the cancer type as a, diagnostic, but also to monitor, for example, chemotherapy, when to give a drug, when to stop a drug. So that means this is leading to typically leading to personalized medicine. And we are also have a portfolio of developing diagnostic for Alzheimer's disease, wherein you are using both molecular science and nanotechnology. With that, I think I have come to an end almost. So there are some example of monitoring and treatment. Probably I'll skip this. So across India also there is a lot of things are happening, in terms of IITs and IASC. To summarize, nanotechnology or nanobiotechnology impact all spheres of human lives. So there is academic in this. So we must translate this academic research at this stage. And there is of course there is a rapid development. So R&D support is always essential. And one more thing I forgot to mention. The toxicology of nanomaterials needs a special mention, although we are not working ourselves as such, but irrespective of whether these materials in the material domain or in the biological domain, I think the nanotechnology, this toxicology of this nanomaterial needs to be studied. With that, I would like to thank you. And now we may go back to New Delhi, and Dr. Robert Luck can talk over.
Thank you very much, gentlemen, for your very, very interesting presentation. It's really an eye-opener and impressive about the wide range of applications in nanotechnologies in the various fields. Ladies and gentlemen, we have a few questions in our audience, and I would like to start. Perhaps there was a question asked to Mr. Siddhalingaya, the company testimonial. It was not clear to one of our some gentlemen from our audience about the exact application of nanotechnology. In your particular case, I understand it's of course the sensor technology, but perhaps you could elaborate a little bit more on this.
Yeah. As I mentioned, we are talking about digital technology, but entire world is in physical format, analog format. I have so many parameters that needs to be sensed. In case of agriculture, soil parameters, soil moisture, pH, electrical conductivity, many things. I cannot make individual components to measure this. Can I bring all these things together and make it as a lab on chip or system on chip? Here's something what I'm expecting. And most importantly, very compact and low power consuming. I cannot run my main wires in the remote location. Can you bring out all these technologies in a very compact format? So my understanding with micro and nanotechnology, it should be possible.
Thank you very much. There is another question to Professor Sen. Very interesting presentation from this side. I have to emphasize, Professor, thank you very much. You mentioned so many applications, mobile diagnostic labs, antimicrobial surfaces, massive single protein. And in one of your charts, there was also a company mentioned there, Tata Trusts. The question of is how do you get in touch with the private sector? Is it more from, are you proactive from your side, or is it the private sector who is approaching you with certain questions, ideas, possible applications? How does it work?
So for our case, it works both ways. So there have been companies which have approached us with specific problems, and then we have a mechanism internally, because we handle, as I showed in one of the slides, that we have industry affiliates. So there's a program. That program actually allows us to link the particular company with the particular faculty who might be able to work with the company on that specific problem. So that is one way of doing things. We have also, that industry affiliate program has also gone aggressively outside and talked to different companies at different venues, in trade shows, and tried to find out if they would be interested in visiting SENS, looking at their capabilities, knowing more about the general research that is being done, and whether there would be an opportunity of collaboration or some kind of project that people can do together or support.
Thank you very much. Perhaps one more question to our first presenter, Dr. Gowda. One of our participants at this webinar has been asking, who are the major players, Dr. Gowda, in Karnataka, the startups? So who are actually the superstars? Can you
see the Department of Information Technology, Biotechnology, and Science and Technology. We have been promoting the startups in the government of Karnataka. In the biotechnology, we have a biotechnology startup company, and in the information technology, also actually we have with NASCOM we are having a tie-up, and we have a startup. So Nano also could be incubated in those places. And of course, at Indian Institute of Science itself, they have a place for startup, and also at the Indian Institute of Technology, Mumbai, they have a place for startup. In fact, they encourage the startup and use their facilities. Yeah, thank you.
Thank you very much. I want to add that I myself had the privilege to visit your startup center, NASCOM, in Bangalore, and it's really impressive to see these companies working there very hard and to try and to be successful, and many of them are. So it's really impressive, active, very dynamic action going on there, and I wish you all the best of success. Ladies and gentlemen, this brings me to our upcoming events. This is of course addressed to our audience in Austria. We have a few events coming up with regards to nanotechnology and startups and innovation. As you might know, the Austrian Trade Commission New Delhi is also the innovation center. And we have a few events coming up, which I would like to mention to you briefly. In September, we're going to have innovation learning journey on nanotechnology. You will receive further information on that, and I hope there will be broad participation in from the Austrian side. I have just, so that will be from the 23rd to the 27th of September, learning journey nanotechnology in Bangalore. So this event here, this webinar should have been a teaser for this. You should have made your interest, and I think there is sufficient interest will be created from this wonderful presentation we heard today from our presenters. In November, we have the Health Tech learning journey to Bangalore and Pune as well, from the 18th to the 22nd of November 2019. And finally, in December, startups, innovation, new technologies, learning journey to Bangalore and Hyderabad. This is basically addressed to innovation managers. All of these events, it's not a sales event, it's not a procurement event. It's actually a learning journey, as the name says. We would like to show our Austrian companies about these amazing startup scenes in these cities, and they are the leading cities in the world in the meanwhile, as we have heard. With that, ladies and gentlemen, I would like to thank very much again our presenters for the time they took for their very interesting presentations, and I would like to thank also the audience for listening in. I hope to see you, maybe some of them getting to know you in person on one of our upcoming events, which I have shown to you. Thank you very much for participating, and good luck, and hope to see you soon. Thank you very much. Bye-bye.